Welcome back to the deep dive. Our mission today is all about decoding the blueprint of the bilingual brain.
hmm
You've probably seen it. That person who just effortlessly switches between languages, maybe even mid-sentence, it looks like. Well, like incredible agility.
It does.
So the question is that just some kind of magic? Or is it measurable neuroplasticity written, directly into our gray and white matter?
Mm.
Okay, let's unpack this. We've pulled together a really rich stack of sources for you today. We're talking everything from advanced MRI studies, looking at brain volumes, cortical thickness in kids and adults.
All the way to real-time electrophysiological studies.
Exactly, tracking the brain's response to conflict in milliseconds. And the findings are, frankly, stunning. They lay out this hard evidence that the dual language experience, it doesn't just teach you new words.
Not at all.
It fundamentally alters your brain structure. It optimizes how you process things, and it provides what really looks like a powerful, lifelong defense against aging.
Even against neurodegenerative disorders like dementia.
Right.
And if we connect this to the bigger picture, what you see is this powerful story about demand and adaptation.
Right.
The continuous, really demanding task of managing two language systems, making sure the right words come out at the right time, suppressing the wrong ones. It puts this unique, sustained pressure on the brain.
A constant workout.
A constant workout.
No, mate.
And our sources really synthesize the data that explains why this experience is such a potent force for adaptation, from the way the outer cortex is literally sculpted in childhood.
All the way to how the brain's internal wiring is maintained robustly well into old age. So let's start with the physical hardware then, the gray matter.
Good place to start.
For anyone listening, you can think of the gray matter, the cortex, as the main factory floor of the brain. It's where the thinking and the processing actually happen.
Right.
We know that complex tasks can, thicken or expand that factory floor, but what does learning a second language actually do to it?
It sculpts it. But, and this is the key, not uniformly, there was a fascinating study out of McGill that looked at monolinguals versus bilinguals.
And they separated the bilinguals by when they started, right?
Exactly. What researchers call the age of acquisition, or AOA. So simultaneous, which is under 3 years old, early sequential, from 4 to 7, and late sequential, 8 to 13.
And the findings in the inferior frontal gyrus, the IFG, that's where it gets really compelling, because it's not the same on both sides of the brain.
It's a striking asymmetry. The IFG is just so critical for language control. And on the left side...
Which is usually dominant for language.
Usually, yes.
Yeah.
On the left, they found the cortex was significantly thicker in both the early and the late sequential bilinguals compared to monolinguals.
Which, okay, that makes a kind of intuitive sense. You add more demand, the brain adds more cellular capacity.
It's like adding more workstations to the left side of the factory floor, precisely.
So the left side builds up to handle the load. But if the left side is building up, what on earth is happening on the right?
The right side, the right IFG, tell the complete opposite story, especially for the late learners.
The opposite.
This region showed a significant reduction in thickness in those late sequential bilinguals compared to every other group.
That feels wrong. Why would a part of the brain shrink when it's working harder? Is there any risk that this thinning is, a sign of some kind of functional loss?
That is the key question.
Yeah.
And the interpretation here isn't loss, it's optimization.
Pruning.
Pruning. The brain is adapting the architecture to be more efficient. Since the late learners had to consciously integrate a new system, the brain consolidated resources on the dominant left side and, well, pruned less essential processing space on the right.
So it's making the machinery lean and efficient for dual language control.
Yes,
Yeah.
a structural fingerprint of efficiency.
And it's established based on when you start learning. But these changes, they aren't just for adults who've been doing this for decades. The research shows this starts happening incredibly early.
Oh, very early. In
Yeah.
studies comparing, say, early Spanish-English bilingual children to their monolingual peers, you can already see robust differences in gray matter volume, or GMV.
And what's fascinating is where those volume changes are.
Right. You'd expect the classic language areas to just balloon.
But that's not what the data showed.
No, the bilingual kids had greater GMV in regions tied to domain general executive control.
The brain's management system.
Exactly. Areas in the frontal and parietal cortices that handle attention, task switching, inhibition. It supports the idea that the demands of language juggling are already reshaping the brain's managerial systems in childhood.
So the brain boosts the manager's office first, because the biggest challenge of bilingualism isn't knowing two languages, it's managing them.
Precisely. And the surprise finding really reinforces that. Contrary to what you might expect from adult studies, these bilingual children actually had less GMV in some classic left hemisphere language regions. Less. Which suggests that while the brain is building up the resources for switching and control, it might be achieving linguistic efficiency processing language faster, maybe more compactly, instead of just adding bulk everywhere.
Okay, so we've got the gray matter, the processing hubs being sculpted early, but that's only half the story. If gray matter is the factory, we have to talk about the connection lines, the white matter superhighways.
Absolutely. The integrity of that white matter, the WM, is crucial for how fast information gets from A to B.
And it usually declines with age. The highways get crapped, they slow down.
They do. But studies on older, lifelong bilinguals show this powerful protective effect. It directly counteracts that age-related decline.
They don't just have normal WM integrity for their age. They actually have higher integrity than their monolingual peers. That's incredible.
That's right. It's really measurable structural evidence for what we call brain reserve. You can see this maintained integrity in critical tracts, like the corpus callosum.
The massive bridge connecting the left and right hemispheres.
That's the one. It stays robust. And we also see it in the superior and inferior longitudinal fasciculae, which handle a lot of that fast, long-distance communication.
So because the brain is constantly required to move information back and forth rapidly to manage two languages, it invests in keeping those highways paved and fast for a lifetime.
And that structural robustness translates directly into function, because bilinguals need coordination across multiple, often distant regions, Broca's, Wernicke's, the prefrontal cortex. They develop functionally stronger networks.
So we see this in older bilingual.
We do. They exhibit stronger anterior to posterior functional connectivity.
Yeah.
They're just running a more integrated, coordinated operation.
But let's go back to that paradox we touched on earlier with age. We said the gray matter changes are robust in childhood.
Right.
So if learning a language is like intense training, shouldn't another 50 years of practice lead to, bigger and bigger GMV differences?
That was a powerful hypothesis. I mean, it makes sense. You see it with other skills, like the London taxi drivers whose hippocampus grows with navigation practice.
But it wasn't supported here.
Largely not supported, at least for gray matter volume. The structural impact seems to be established pretty early, around age 9. After that, there's actually very little further divergence into young adulthood.
So the structural blueprint for managing two languages gets laid down early, like a building's foundation. And the lifelong benefit isn't more building, but better maintenance of the roads, the white matter.
That's a perfect way to put it. The cognitive advantage shifts from building a bigger factory to ensuring the roads leading to it stay perfect and fast for decades.
Okay, so we have this brain with an efficient early blueprint and better maintained connections. What does this all get us on a practical cognitive level, especially as we get older?
It leads to a massive boost in something called cognitive reserve. All that linguistic juggling forces the brain to strengthen synapogenesis.
The formation of synapses.
Yes, and that essentially builds resilience. It makes the brain more robust against physical insults, including the ones that cause cognitive decline.
But the most precise evidence comes from looking at that executive control efficiency at the millisecond level, using those electrophysiological studies.
Absolutely.
They show that bilinguals don't just solve nonverbal conflict problems, they solve them fundamentally differently.
They really do. When you present them with a cognitive conflict, a task where they have to ignore a distraction, bilinguals consistently show signs of earlier and faster processing. They're much quicker at automatically detecting the conflict and categorizing what they're seeing.
They flag the conflict almost instantly.
Instantaneous.
And the really incredible part, for me at least, is what happens next. If they solve it faster, what does that mean for the later stages of processing?
It means efficiency, less stress on the system. In the later processing windows, the slow, deliberate thinking phase bilinguals shows significantly reduced brain activity.
Because they already did the work.
They front-loaded the cognitive work, so they need fewer neural resources for that later, controlled error checking and conflict resolution.
It's like having a superior early warning system. You don't need to deploy the full, expensive emergency response team later on.
It is. It's a fundamental reallocation of resources.
Yeah.
And researchers actually have a name for this cumulative effect: the bilingual anterior to posterior and subcortical shift, or BAPSS.
Okay, that's a mouthful. What does the BAPS model tell us?
It tells us that with all this dual language experience, the brain shifts how it recruits resources. It moves the effort away from the frontal-controlled later processing regions.
And moves it where?
toward more automatic earlier processing in posterior and subcortical regions. These areas start to handle the language management more automatically.
So the job moves from the slow conscious centers to the fast automatic subconscious ones.
Precisely. And the functional result of that is profound, especially in older age. Because those critical frontal control resources, the ones that naturally decline with age, they remain available.
They're not being constantly taxed by routine language management.
Exactly. They are preserved for truly challenging, novel tasks. It's an effective way to combat typical age-related decline.
And the ultimate payoff. The life-changing benefit of all this optimization is the delay of neurodegenerative disease. And this is not a small effect.
No, the delay is substantial. It's been confirmed across multiple studies. Bilingualism is associated with delaying the onset and diagnosis of dementia and Alzheimer's by an average of 4.3 to 4.8 years.
Almost 5 years.
Just think about that. An extra 4 to 5 years of high-quality cognitive life. For an individual, for their family, that's a massive, massive impact.
And are there factors that make that protective effect even stronger?
Yes. It seems to be predicted not just by being bilingual, but by the degree of proficiency in each language.
So higher fluency means more protection.
A greater reserve, yes. And there's even some evidence that if you speak more than 3 languages, the protective effect might increase even further. The level of engagement really matters.
Okay, that's the hard neurobiology, but let's bridge this to the subjective reality, the actual experience.
Right, what it feels like.
Because for a monolingual, switching languages sounds like this complex, slow process of translation in your head. Is that what it's like?
Rarely. Not for fluent bilinguals. They typically don't translate. They go straight from, raw language to meaning.
So if you think of a dog,
The word dog, perro, chien,
they're just different synonyms tied directly to the same abstract concept of a dog. They aren't intermediaries that need to be translated from one to the other.
and when you ask people to describe the actual act of switching, the metaphors they use are just fantastic.
They are. It feels incredibly fluid. People describe it as flicking a switch or changing modes or even accessing a different database.
It's not a struggle.
No. One description I loved likened it to choosing a different instrument to perform the same melody. The abstract thought is the melody, but the output mechanism changes.
And what about code switching? That natural mixing of languages mid-sentence that you hear all the time. To an outsider, it can look like confusion, but it's generally a sign of efficiency and comfort, not confusion. It happens naturally, especially when people are tired or excited or when the perfect word is just faster or more precise in the other language.
You're just drawing from the full integrated vocabulary you have available.
Exactly. You're maximizing your expressive utility.
Which is a crucial reminder. I think many of us in places like the US or the UK, we tend to view monolingualism as the standard, the default.
But on a global scale, that's statistically just
Yeah.
not true. According to sources like Ethnologue, multilingualism is the default state for the majority of the world's population. It's the norm, not the exception.
Wow.
And the neurological benefits we've been talking about really underscore why this pervasive, lifelong cognitive engagement is such a powerful human advantage.
This was a dense, wow, an incredibly rewarding deep dive. If we just summarize the timeline of benefits here, early exposure creates a robust structural foundation. You get that optimized gray matter blueprint in childhood. Then, lifelong practice ensures you maintain your white matter integrity for decades.
And the culmination of all that
Is an executive control system that's faster, that needs fewer resources, and that delays the clinical onset of dementia by nearly 5 years.
And this raises an important question that I think goes beyond just language.
How so?
Well, the continuous mental gymnastics of managing 2 systems, it results in this structurally and functionally optimized brain. We have clear evidence that this kind of early and continuous cognitive demand produces a quantifiable brain reserve effect.
So here's where it gets really interesting. If the high engagement task of bilingualism, learned in childhood and maintained into older age, provides this level of protection.
What other similar lifelong skills might do the same?
Right. What about things like advanced musical training or complex spatial navigation, or maybe certain highly demanding jobs? Could they produce a similarly quantifiable protective structural effect?
It makes you wonder, doesn't it, about the untapped power of neuroplasticity that's driven by sustained commitment.
And that's something for you to mull over as you continue your own learning journey.